Jackie Quinn, Project Manager for PRIME-1. You're launching next week. It's a real pleasure to have you on Australia in Space TV, and we're here at the Kennedy Space Centre with NASA. Thanks for joining us.
Oh, you're welcome. Lucky you're here on this cold February morning.
Look, we would have been outside. Yeah, that's right. Yeah, and we do appreciate the short notice as well. But again, you're just days away from a launch. And PRIME, did you come up with the acronym first and then use the words to suit it? Given it's the Polar Resources
Ice mining experiment.
Right.
Yeah, I actually came up with the acronym a long time ago. It seems like we've been working towards this inevitable launch here next week for a while. But we've been interested in the resources in the South Pole region of the moon for, many years, and so finding the right way to express that in something that's easy to roll off the tongue was pretty easy. You know, PRIME-1 is, I was hoping there'd be PRIME-1, PRIME-2, PRIME-3.
Yeah.
Only got PRIME-1 going so far, but it's a unique opportunity to get a look down below the subsurface to see if there's any trapped gases, frozen gases sticking to the lunar regolith. We call it regolith when it's on the moon or soil. And then also to get a lot of the engineering data as we penetrate into the surface, and that's going to help our ultimate Artemis goals.
So you've got a mass spectrometer on there as well, M-SOLO as well. So these two units will work together. I suppose what's the expectations on sort of the data and the science that you'll get out of it? Is basically to confirm that there's water on the moon?
Well, we have confirmation from orbiting assets that there is evidence of water on the moon, and it's very much located in areas that don't see a lot of sun for very long, solar heating for very long. I want to just step back and say PRIME-1 is made up of two instruments, right? So collectively they work together. They're controlled separately, but they work together. The drill is has a capability of taking samples down to a meter below the surface, and then M-SOLO, that instrument's called Trident. The regolith ice drill. I'll give Honeybee Robotics pure credit for that. The regolith ice drill for exploring new terrain, and then there's M-SOLO, which is mass spectrometer, observing lunar operations, and they work together in that the drill takes discrete samples down to a meter depth and brings them up to the surface and deposits like 10 centimeter bites on the surface in a conical shape. So it's just gravity drops the lunar regolith onto the surface. And in that action of doing that, of depositing on the surface any volatiles or gases that are frozen and absorbed to those grains, there's enough energy in that activity of drilling it up and then the mechanical dropping it onto the surface that they will come off in the vacuum of space on the moon. And when they do, then that's when M-SOLO pops in and starts to analyze those gases for both which gases are we seeing and in what quantities.
And it's doing that in situ as well, but I understand you're controlling this from Earth as well, so it's not a sort of an autonomous process?
Yes, no, it's not autonomous. Our control room here is at the Kennedy Space Center. So we'll be sending those commands from the ground station here to Intuitive Machines, and then they upload it through their satellite system that's their lunar network, and sending those commands from Intuitive Machines, which is based in Houston, Texas. So we'll start the command here, send it to Houston. Houston uploads it to the vehicle, the lander, and then the lander sends it over to PRIME-1.
And does that impact the experiment at all in terms of the delayed comms and then you're sort of getting that back? Because this isn't mobile, is it? So once it's land, it's fixed?
Yes, it is a static payload, meaning it is bolted to the lander, and it doesn't, it's located up tall on the lander, and their Intuitive Machines has a mechanism to lower it down to the surface. That's the only mobility that it has, is coming from a up high stored position to a lower position, but it's not on a rover or any mobility device.
But that's in the roadmap, is it not, to put sort of some testing onto the moon rovers and the vehicles, so they can move around? Because you got to get that spot. What part of the moon is this landing on? This is landing on Mons Bouton, which is in the South Polar region. So it's confirmed that there's water there. You just don't know how much. What's sort of the outcomes here? Will you sort of be able to extrapolate sort of what those readings are and then go, okay, well, these are the readings in one location? You'll then extrapolate that to sort of estimating where else it is, or
right.
how much?
So we do have orbiting assets that give us an idea of the thermal environment across different areas of the lunar South Pole. That is from the Diviner instrument that was sent many years ago and is orbiting the moon currently, right? So we get that thermal data and we use modeling to predict what the temperatures are on the surface of the moon. And those temperatures will tell us, is it cold enough to keep gases frozen and in a state where they can not sublimate off into the vacuum of space. And so there are different areas that have higher probability of finding frozen gases and others that would lend itself less likely. Yeah. We don't have confirmation of that yet, but regardless of finding the actual volatiles itself, we're going to get a lot of information about geotechnical type of engineering data. Yep. That's going to help us in future endeavors on the lunar surface, like building habitation systems, understanding how much a launch pad environment can take, and if there are gases present at the surface or in the near surface, like down to a meter, then how much are there and not. So regardless of whether we hit something with water, we'll find other gases there as well, we anticipate.
Has there been drilling done before? Because a metre doesn't sound too far, but what are you anticipating in sort of the, because regolith is sort of a challenging sort of soil type in its own right.
Yeah,
what's
it is,
like
for sure.
A metre down? What's your expectations there, and how much force is going to be required from a drilling perspective?
Well, we don't know.
Okay.
We've never been to the South Pole before, and we don't have that data. Nobody does. So it'll be the first time that we've actually drilled robotically from Earth and drilled on the lunar surface in the South Pole region. The last time the U.S. drilled was during the Apollo era, and it was a human astronaut was actually doing the drilling. And this is all going to be robotic from Kennedy.
Got it. How far did the flag go down when they did? I'm just wondering what's the
I have no idea.
Okay.
Couldn't tell you.
And I suppose, how long will the experiment go? It's just going to take those samples and that'll be it? Will you be able to come back and take some more into the future? How long's the mission, I suppose?
So we are contracted with Intuitive Machines for a set number of hours that we can operate. So we expect to be done within roughly 72 hours after we start the drilling process and taking those samples. We have a lot of science holds built in. Our science team will be looking at changes that are happening across that timeline, but we do have just that 72 hours available to us. The mission isn't very long to begin with, right? But we're excited to get those first data.
Working on this mission then? It's only going to last for 3 days.
No, well, it's kind of a circuitous path, actually. We started with a mission we called Resolve back in 2007, and that's when I joined the ISRU, or In Situ Resource Utilization team of folks. And so we started with Resolve, which was a little bit more than M-Solo. It was M-Solo drill and another series of instruments that would help, and that evolved into other missions. So I guess this is the first one I've got to fly, and it started in 2007 for me. For our project scientist lead, it was, I think, a year earlier than that.
Wow,
so,
okay.
Yeah.
So you can't be more excited, obviously. What your background? What's your background?
My undergraduate's in civil engineering,
Right.
and then I have my master's and doctorate is in environmental engineering. Specifically, my areas of research were environmental cleanup. So when my boss asked me to start on working on this project, I was doing a lot of terrestrial drilling here on Earth, drilling and evaluation of groundwater and stability of the groundwater system and if it was contaminated or not. So I'd done a lot of drilling here in the U.S. With partners that he said, oh, but maybe you'd be good to work on this project. And I'm like, I've done a little drilling. Let's go drill on the moon.
To be on the moon.
And it has to do with water. So
Look, that's so fascinating. We've done some Space and Earth conferences in Perth, and the interest in resources and mining as well. Just in the design of the drill and the science being gathered out of this, is there any on-Earth applications that have come out of this? Yeah.
Ooh, that's a really good question for Honeybee Robotics. They're the ones that designed and built the drill. The drill is a auguring, percussive auguring drill, so it has the ability to both turn and then pound depending on how hard of a rock they encounter. So, as far as feed forward, I guess I'd have to defer you to Honeybee.
Yep. There was, in the notes, I think there was sort of described what it was made of as well. Yeah, any particular design in it because it's going to be on the moon? Anything changed? And has it been tested in microgravity? Was it taken up to the space station or something like that?
Nope, it wasn't tested there. I think some of the unique design capabilities of the instrument, in the very tip of it, it's only, about an inch in diameter, so it's pretty small. And in the very tip of it, there's a temperature sensor that can give us downhole temperature measurements. And that's really interesting because we've never ever been able to get a downhole measurement of the temperature. So it's going to really feed forward into some of the models. And I talked about earlier about how we use orbiting assets to predict where these volatiles might. We'll be able to do some corrections on the models and what we think might be there and what we actually recorded. So we actually plan in our operations for PRIME-1 to do discrete temperature measurements. So we're going to drill down to a certain depth and let that drill sit there and come to equilibrium and get a good as close as we can accurate temperature measurement at depth. And we'll do that 3 times at different depths, which has really not been done before. And I know the modelers and the scientists out there will be really interested in getting all that data.
I take it there'd be some guessing and sort of checking their own theories and whether that's proven right or not, right?
And adjusting.
Okay,
but that's the normal scientific method, right?
Yeah.
So.
Well, look, and the whole mission itself is quite interesting. There's a couple of other sort of operations going on with intuitive machines as well. I suppose finishing up, you mentioned PRIME-2 potentially, PRIME-3, we'll see. What's next for you? Will this project continue on in terms of the science, or once it's completed, you sort of turn to your next project? What's kind of next after this?
So what we'll do when we land and get the data back, we will digest that data, put together what that data interpretation looks like, publish on it, and then all of the science data, as with NASA normally, is their protocol, will be uploaded to the planetary data system for public. We are a public government agency, so so that'll happen. Over the course of several months after the mission, is that data is uploaded in the planetary data system. As far as future, we have a couple of other mass spectrometers and drills that are planned eventually for flight. Working those into a manifest is in our current plan, so that's what we'll pivot to.
Well, I suppose with the Artemis moon and Mars, you do have a long-term job here, I take it, in terms of this will continue on. This is sort of the first drill or the first shovel into the ground on the moon towards sort of colonisation and the like. Yeah,
somebody asked me, what does it mean to you to be part of this mission? And I think it's really searching for the right words. It means a lot to be part of the beginning. Yep. I always have people, say, "Oh, are you thinking about space?" I'm like, there is so much space out there. There's competition, whatever. There's a lot of space. Let's go find out. And to think about colonization and living off planet, it's going to happen.
Exactly.
Right? And may not be in my lifetime, but my kids or my grandkids for sure.
Yeah.
And that's quite a unique perspective to have when you sit there and say, I was part of that first sample.
It's why I've come all this way to talk to you. In fact, a Falcon 9 rocket took off.
Oh, did you get to see it?
Yeah, that's right. But when you're coming on the way to NASA to see another rocket flying, as you say, it is happening in
very soon.
Early days as well, but there's a long way to go. Yep. Look, Jackie Quinn, Project Manager for PRIME-1 here at the Kennedy Space Centre with NASA. Thank you so much for joining us today on Australia in Space TV.
Thanks.
Our audience will be very pleased and surprised that we got this at short notice. And best of success next week for your launch.
Thank you. And I guess we're going to see you Eclipse coming to Australia in 28.
Absolutely.
Oh,
in
my
fact,
gosh.
I've got socks for IAC Sydney. I don't know if you're coming down to IAC, but hopefully you can.
Cool.
Good on you. Thank you.
All right. Thank you.